law that explains the relationship between the pressure and volume. This is something that we apply in our daily lives, such as breathing, inflating tires, working with syringe, and many more, that sometimes we didn't know we are doing or applying it. And this is what we call the Boyle's law.
In the year 1662, Anglo-Irish chemist named Robert Boyle, who was known as the 17th century pioneer of modern chemistry, proposed the ever-famous Boyle's law, which states that the pressure and the volume of a gas are inversely proportional. When we say inversely proportional, when the pressure increases, the volume decreases, and when the volume increases, the pressure decreases, assuming a constant mass and temperature.
Now, for you to better understand what we can say, let's try some experiments showing the relationship between the two.
First, we need a needle syringe and a marshmallow as our material for this experiment. Next is put the marshmallow inside of the syringe and cover the tip of the needle. And slightly push the plunger. As you push the plunger, the pressure is increasing and the volume of the marshmallow is decreasing.
Now, we need the plastic bottles, balloon, straw, and water as our materials for the experiment. Now, let's first put a hole in each bottles wherein we will put the straw. And lastly, let's inflate the balloon in the bottle with water. As you can see, as the air in the balloon is released into the bottle, pressure inside increases, so the volume decreases, making the water inside the bottle decreases by entering the straw and go to the other bottle. In conclusion, we can say in this experiment that when the pressure increases, the volume decreases. And that is the very essence of the Boyle's law.
Now, let's go back in tackling this law. But before we dig deeper, the computation of the Boyle's law, there are some quantities and symbols that are important and relevant in this.
First, we have the P, which stands for pressure. Second, we have the V, which stands for volume. Third, we have the T, which stands for temperature. And lastly, we have the K, which means constant.
Choose, it leads us in a mathematical equation in computing Boyle's law, wherein P1 stands for initial pressure and P2 stands for final pressure. On the other hand, V1 stands for initial volume and V2 stands for final volume. Let's start solving.
A gas occupies 12.3 liters at a pressure of 40.0 millimeters of mercury. What is the volume when the pressure is increased to 60.0 millimeters of mercury? First, is we analyze the question. As we see here, the missing one is the V2. Now, let's proceed in identifying the given. The initial pressure or P1 here is equals to 40.0 millimeters of mercury. The initial volume or V1 here is equals to 12.3 liters. And next, the P2. It states in the questions that the pressure is increased in 60.00 millimeters of mercury. Now, let's compute the V2. P1 V1 equals P2 V2. Then, let's substitute the given and we will have the equation. 40.0 12.3 equals 60.0 V2. And since we look for V2, we need to remove the 60.0 in the equation by dividing it to both sides. 40.0 millimeters of mercury, 12.3 liters equals 60.0 millimeters of mercury V2 over 60.0 millimeters of mercury, 60.0 millimeters of mercury. Cancel the 60.0 in the second sequence and we'll have 40.0 millimeters of mercury, 12.3 liters equals V2 over 60.0 millimeters of mercury.
Proceed on computation. 40.0 millimeter mercury multiplied by 12.3 liters divided by 60.0 millimeter mercury, and we'll have 8.2 liters. Therefore, our V2 is 8.2 liters, and it makes sense since as we analyze the given, the pressure increases. It means the volume must decrease, and from its initial volume, 12.3 liters, we have computed our final volume that is equals to 8.2 liters, which means the volume decreases.
Now, in number 3, first is we need to analyze the question. As we see here, the missing one is the P2. So we need to compute for it. Now, let's proceed in identifying the given. The initial pressure, or P1, here is equal to 0.860 atm. The initial volume, or V1, here is equal to 11.2 liters. And next, the V2, which is equal to 15.0 liters. Now, that we have their values, let's compute the P2. P1, V1, P is equal to P2, V2. Then let's substitute the given and we will have the equation. 0.860 atm, 11.2 liters, is equal to P2, 15.0 liters. And since we'll look for P2, we need to remove the 15.0 liters in the equation by dividing it to both sides. 0.860 atm, 11.2 liters, is equal to P2, 15.0 liters divided by 15.0 liters and 15.0 liters. Cancel 15.0 liters in the second sequence and we'll have 0.860 atm, 11.2 liters is equal to P2 divided by 15.0 liters. Now, proceed in computation. 0.860 atm multiplied to 11.2 liters and then divided it by 15.0 liters. Therefore, our P2 is equal to 0.642, and it makes sense since as we analyze the given, the volume increases. It means that the pressure must decreases, and from its initial pressure, 0.860, we have computed our final pressure that is equal to 0.642, which means the pressure decreases.
Miss, no one asked, but no, name nga kasi
Bottle. To fill our straw.
Huh?